Hey guys, Mr. Martin here with today's video on how to prove triangles are congruent by SSS. SSS stands for side, side, side. So here we go. Alright, the first thing we're going to do in this video is discuss the SSS congruence postulate. Again, SSS means side, side, side. Okay? If three sides of one triangle are congruent to three sides of a second triangle, then the two sides are congruent. To be more specific, if side AB is congruent to side RS, and if side BC is congruent to ST, and if side CA is congruent to side TR, then we can say that the two triangles are congruent. And remember, the order that the letters are written in absolutely matters. So the first side is AB and RS. So you notice we've got AB and RS written first. Okay? Then we have BC congruent to ST. So we have BC and ST. Okay? And lastly, we have CA and TR. So we have CA or AC and TR or RT. Okay, remember from last video, the order matters in the congruent statement. Alright, let's use these in a couple of examples. Okay, so let's say we're given this picture and we're told that KL, segment KL, is congruent to segment NL. So KL is congruent to NL. We're also told that KM is congruent to NM. Okay? So we've got two of the three sides. All we have to do is prove that that third side is congruent on both triangles, and we'll have it. I think you know as well as I do that if they share a side, the side that they share in the two triangles is obviously congruent to itself. So if you split that picture in half, the side LM of the left triangle would be the same side LM of the right triangle. Okay? And you remember that being the reflexive property. So pretty straightforward proof that all three sides of that triangle are congruent to each other. It's a real simple proof. The two triangles must be congruent to each other. Okay, we're going to talk a little bit about why that has to be true, but for right now, just remember, if three sides of one triangle or three sides are congruent to three sides of the other triangle, the two triangles must be congruent. Alright? Alright, I want you to try a couple. I want you to look at these diagrams and tell me whether or not the congruent statement is true or not. If it's true, explain why. If it's not true, explain why. So pause the video for just a second, take a really close look at those pictures, and tell me if those are congruent or not. Alright, we're back. Hopefully those were not too difficult for you. I got pictures, or statements 1 and 3 being congruent, and number 2 not being congruent. So let's take a real close look why. Okay? So remember, the order of the letters matters on the congruent statement. So let's take the first picture. We got DF and HJ. So we got DF is the one that has 2 tick marks on it. HJ has 2 tick marks on it. So we can say DF is congruent to HJ. That's one pair of sides. Okay? Let's take the next two letters. We got FG and JK. So FG has 3 tick marks on it, and JK has 3 tick marks on it. So we can say FG is congruent to JK. That's the second pair of sides. Okay? And of course, these are all segments, right? So let's make those segments. And then the last pair of letters. We got DG and HJ. So we got DG and HJ. So we have segment DG being congruent to segment HK. That is the third pair. So we can say that statement is true by side, side, side. Okay? Number 2. I said that those were not going to be congruent to each other. Let me show you why. It's pretty darn obvious right here. You got 3 is obviously not congruent to 4. Remember, as soon as you find a counterexample, just one pair of sides that's not congruent to each other, you can stop. Okay? We have AB supposed to be congruent to CD. You know as well as I do, 3 does not equal 4. So we can say that AB is not congruent to CD. Therefore, triangle ACB is not congruent to triangle CAD. It's a big nope. Okay? Alright, last one real quick. QP and RS. So we got QP and RS. That's a check mark for 1. Okay? Then let's go through PT and ST. That's number 2. And then finally QT and RT are congruent. QT and RT are congruent. That's number 3. So we can say that that one is true by, you guessed it, side, side, side. We're going to have some other reasons why triangles are congruent, but for right now, the only one we have is side, side, side. Okay? All right. Here's an example where we put a triangle on a coordinate plane. Okay? So it's asking us which of the following are the coordinates of the vertices of a triangle congruent to triangle PQR. So let's look at the side lengths of triangle PQR. First, just by counting, I think you can see that side PQ is 4 units, side QR is 3 units, and side PR is 5 units. So if we can find a triangle that has a 3, 4, 5 measure on their sides, then I think we found it. Okay, so let's look at some of these. If you remember, if we have the same x values, all we have to do is count the difference between the y values, because that will be a vertical line. These two have a distance of 4, so that's one that matches. These two have the same y value, so we can count the distance in x's. That's the distance of 3. And then these two don't have the same x's or the same y's, so we have to double check the distance by the distance formula, and we remember the distance formula is we subtract the x's and square that value, and we add that to the distance between the y's squared, and then we take the square root of that big number. So from -1 to -4 is 3, and from 1 to 5 is 4. So let's check to see if that gives us a 5. So 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, so the distance is 5. The distance from the first point to the last point is 5. So I think we found our triangle that has the same side lengths, and we are done. Okay? I think we can go through some of these real quickly and disprove that these are the values, but we don't want to waste time in the video. If you want to work through each one by the distance formula and prove that they're not congruent, you can go ahead and do that. Alright, let's move on. And there's the short example for you, with the solution written out for you. And you can copy that in your notes if you don't already have that down. Alright? Alright, here we go. You try one on your own now. I want you to graph those two triangles, and I want you to prove or show that they are congruent to each other. Okay? Pause the video and come back when you're done. Alright guys, if you're back, hopefully you were able to prove that these two triangles were congruent. Let's take a close look here. Let's do the red triangle first. Okay, I went ahead and plotted the points. Now I'm just going to look at the side lengths. That obviously has a side length of 3. This has a side length of 6, and this I don't know, so I'm going to use the distance formula. The difference in the x's is 3, and the difference of the y's is 6. So I get a distance of 9 plus 36. I get a distance of 45, which is the same as 3 root 5. So if these two triangles are congruent, the distances must be the same for all 3 sides. Let's look at the blue triangle. I think you can see that this is a side length of 3, and then the top has a side length of 6, and I think you can see through the distance formula we're going to get the side length of 3 root 5 here. So you can see that all 3 sides match. So these two triangles are congruent to each other. And we just showed that by showing that all 3 pairs of sides are congruent. So we say this is by side, side, side. Alright, so let's move on to what I think is a pretty cool real-life problem. Okay? Want to look at these 2 benches that the football players are sitting on and explain why the bench with the diagonal support is stable while the one without the support can collapse. So if you've done any building or construction work, I think you've heard of cross beams or support beams. Okay? So look at the one on the left. It's got this diagonal support here. Okay, notice it forms 2 triangles. We got the upper triangle, and we've got the lower or bottom triangle. Okay? This one over here on the right is nothing more than a quadrilateral. And I think as we learned last unit, that those quadrilaterals can have a lot of shapes. You could see very easily that this quadrilateral could tilt with no problem and become a parallelogram. Okay, not a rectangle, right? But just a plain parallelogram that has nothing but parallel sides. And once that starts to tilt, the weight of those guys is going to send it right on over, right? Okay, so very simple. The bench with the diagonal support forms triangles with fixed lengths. By the side, side, side congruence postulate, these triangles cannot change shapes. They're obviously going to be congruent to each other. They're always going to stay congruent to each other. That bench is not going to move. Okay, so the bench is stable. The bench without supports is not stable because there are many possible quadrilaterals with the given side lengths. Okay, obviously a rectangle and a parallelogram are not the same shapes, and that side, those 2 sides that are on the left and the right are going to start to tilt, and once they start to tilt, those things are going to come crashing down. Alright, the last thing I want you to do, I want you to pause the video and figure out which one of these is stable. Okay? So what'd you get? This time I got yes on number 2. Actually, it's on number 6, the second one. And I got a big no on numbers 5 and 7. Okay? I think you can see on number 5, it's pretty easy. We need a cross support. That again is like the bench on the right. It doesn't have a cross support. Okay? Now the number 7 looks a little devious because on the top you say that's a triangle. That's no problem. But what about on the bottom? And again, need a cross support either this way or this way. If we put them both in there, they're obviously extra supported. Okay? So there you go. That is our first congruence postulate. We're trying to prove triangles are congruent. We're going to have 3 or 4 other postulates or theorems. So get this one down. This is the most basic one. It's pretty easy. If 3 sides of one triangle are congruent to the 3 sides of another triangle, we say that those 2 triangles are congruent. All right? Make sure you got good notes. Write down questions, you guys. If you have questions about something that was talked about in the video, write down your questions in your notes. Maybe use a different colored pen and then ask those questions in class. All right? Please stop being confused and not asking questions about it. I heard a lot of people after the Unit 3 test say, I'm so confused, and yet you're not asking questions. Work really hard this unit on finding out where you're confused and get those questions answered. All right, we'll see you in class. Have a great day.